All right, so we're going to be looking at another transformation here, dilations. We've kind of seen this before. Remember, dilations, we can enlarge or reduce an image or a figure, but it maintained its shape, just not necessarily its size, okay? Now, this is the kind of transformation that we're going to be dealing with and breaking down its parts, just like the last videos when we went over translations, rotations, and reflection. D here's the the transformation name, in this case a dilation. This guy represents the center of dilation, okay? So where are we dilating from? K is the scale factor. By how much are we going to enlarge it? By how much are we going to reduce it? Then, of course, we're going from our pre-image to our image. Okay, so make sure if you need to hit pause and write that down. Now, what are some real-world examples that you might see this? Okay, well, you might see it in graphic design. Okay, so maybe in some graphic design, maybe in police work, like forensics, okay? When you're dealing with photos, you might have to enlarge them. You might see this in architecture. Okay, so you might see this in architecture, in which you would have to like scale an image, because when you make the real thing, obviously when you're just making the sketches and the designs, they have to be a smaller image, so it's a scaled image of what you're trying to create. Okay, then you might also see this like in eye exams, when they dilate your eyes so that the doctor can have a better view of things that are going on there. Okay, so dilations are actually used quite a bit in the real world, just depending on the different situations they're in. But what does this mean if it is something is dilated? Okay, so what does it mean if something is dilated? Well, it's a transformation. It's, whoops, there we go. A transformation that produces the same shape as the original, but is a different size. Okay, so in other words, we maintain the shape of the image, but not necessarily its size. It could get bigger or it could get smaller, okay? But there are certain properties that remain the same, okay? When we're dilating an image, okay, there are certain properties here, like this says here, that are going to remain the same. That includes angle measures, parallelism, and collinearity. Can't pronounce this. Collinearity, okay? That's the best I'm going to pronounce that, guys, okay? Now, with angle measures, all that's saying is angle measures remain the same from the pre-image to its image. Okay, so the angle measures of the original image are going to remain the same to its image, okay? Then parallelism, any parallel lines that we're dealing with will also remain the same. So parallel lines remain parallel from the pre-image to its image. Okay, so parallel lines are going to remain parallel, going from the original image to its image, okay, from the pre-image to its image. And then when it talks about collinearity, I'm not going to pronounce that. All that's saying is if we have collinear points, remember, if collinear points means points that lie on the same line. If we have collinear points, those points will still be on the same line, okay? So collinear points there we go. collinear points remain on the same line from the pre-image to its image. Okay, in other words, if they were on the same line to begin with, then on the image, those same points will be on the same line. Okay. Now, the only thing that, or I shouldn't say the only thing, but in this case, what they're trying to point out to here, the thing that is not preserved here is the distances, okay? The distances between the points based on where they are in the given image, okay? Now, the distance of the points, what they're trying to say, they move during dilation depends on their distance from the center of dilation, okay? So when we're dilating an image, this is basically what we're talking about. We have the center of dilation, okay? Where are we dilating from? Then we take the original image and we could enlarge it or we could reduce it. In this case, they enlarged the image, but it maintains its shape, okay? But what they're trying to point out to you, though, is that the distance, let's say maybe between, they're looking at P and P primed and B and B primed, those distances aren't the same, okay? Now, the reason for that, they say in going back here, points closer to the center of dilation will move a shorter distance than those farther away, okay? So if it's closer, it's not going to move as far, but if it's further away, it's going to move further, okay? In the example, they say that P primed, that distance is not the same as B primed, which is not the same distance as C primed, okay? Point B is further away, so in our original image here, it's further away than our center of dilation, and therefore the distance it moves is further away, okay? So B primed is a greater length or a greater distance than P primed, okay? Now, what does stay the same, though, is the orientation. Well, that kind of deals with the shape there. The orientation, the shape is maintained, okay? And special points. They're trying to point out some special points that you may come across. The center of dilation is an invariant point and does not move in the dilation. If the pre-image P equals the image P primed after dilation, then the point B was the center of dilation. So all that's saying is, if we go back to here, okay, P moved to P prime, B moved to B prime, C moved to C prime, but O, our center of dilation there, it remains the same, okay? So the center of dilation doesn't move, okay? So if you have a point that doesn't move when we're dilating, that has to be the center of dilation. If it doesn't move, in this case for this point here, that have to be our center of dilation. Okay. Now, orientation, we've kind of talked about what that means before. That has to do with the arrangement and or order of points in a figure relative to one another. Okay, so the arrangement of the points there, that's going to be maintained. The orientation is going to be maintained there. Okay, now the scale factor, that's what's going to play a big role into things for our notes here. The scale factor, that another way to think of it is we could think of it as a ratio. Okay, a ratio of how things change, but it determines how much larger or smaller the image will be compared to the pre-image. Okay, so the scale factor determines how much larger or smaller the image is going to be compared to its pre-image, okay? So that tells us how to scale things from the original image. Now, there are a couple of different ways this can happen, okay? And I've kind of mentioned this before in words. We can reduce something, so that's called a reduction. Once in a while, you might hear it as a shrink. Okay? Or we can enlarge it, an enlargement. And sometimes they say stretch, but I don't necessarily like to call it a stretch because we use stretch for something else. Remember, when we talked about stretching something, we said it didn't necessarily maintain size or shape, okay? But that word is sometimes used, okay? But I'm going to focus on the words reduction or enlargement or reducing or enlarging, okay? In this case, this would be a good example. We start out with this penguin here, and it reduces in size, but notice it maintains shape. Then we take the map of the U.S. and it is enlarged. It almost looks like twice as large as what it used to be, but it maintains shape, okay? So when we shrink, a good example of when we shrink would be like 1/2, okay? It's half the size of the original image, okay? Or if we enlarge something, a good scale factor might be like 2, okay? We are multiplying in a sense, we're kind of multiplying by that scale factor of 2. We're doubling everything. We're doubling its size, okay? Now, what happens if we have a scale factor of 1? Well, if we have a scale factor of 1, there is no change in size from the pre-image to its image. Okay, so a scale factor of 1 just means we end up with the same thing. There's no change in size there. Okay, now what I wanted us to focus on is this last couple pieces here, and then we'll do the rest of this as notes in class together, is what does it mean as far as the scale factor? Well, when I dilate something, let's just look at this example here. Notice we're going from A to A prime, to B primed, and C to C primed, and the order matters, okay? So when I look at the length AB here, that's 4 centimeters, and A prime, B prime, what is that? 12 centimeters, okay? So it's getting bigger. It's an enlargement. This dilation is an enlargement. Well, when I go from 4 centimeters to 12 centimeters, how much more, or how much greater did that multiply by to get to 12 centimeters? Well, 3, right? 4 times 3 gives me 12. In other words, this image is 3 times bigger than its pre-image. And we'll see that same ratio throughout each piece, okay? So if I look at A prime, B prime, and usually you'll see a ratio or a scale written. In this case, it's telling us that we have a 3-to-1 ratio or that the scale factor is 3. Usually you'll see it as the image over the pre-image. Okay, so the ratio in which we're talking about things is the lengths that we're dealing with the image over the lengths of the pre-image here, those size, okay? So when they say A prime, B prime, that's our image, and this, what it's being compared to is our pre-image, okay? So we kind of already did this one over here. We said 12 to 4, right? So we're looking at a ratio of 12 to 4, or if we wrote it as a fraction, it'd be 12 over 4, okay? Well, if I divide that out or reduce it, we know that that ratio is going to be 3 over 1, okay, which is what they're saying here. It's 3 to 1, so our scale factor would be 3 to 1, okay? So if we wrote it as a ratio versus a fraction, it would be 3 to 1 or 3. Okay, so it's 3 times as large, and that's going to be the same thing for B prime, C prime. Okay, if we look at B prime, C prime, B prime, C prime is 16.5, and BC is 5.5. Okay, so using that ratio B prime, C prime, that'd be 16.5 to 5.5, or written as a fraction, it'd be 16.5 over 5.5. Well, we can reduce that. If you divide that out, you're going to get 3 over 1 if we reduce that out. So our scale factor is still the same, 3 to 1 or 3. Okay, so it's 3 times as large. Same thing and similarly with AC and A prime, C prime. A prime, C prime is 15 and AC is 5. So if we're looking at the ratio, that would be 15 to 5, or written as a fraction, 15 over 5, which reduces to 3 over 1. So what's my scale factor? Again, it's still 3 to 1 or 3. Okay, so that would be the scale factor, okay? So it's 3 times as large as the original image, Okay. Then lastly here, before we get into more examples tomorrow, okay, being able to determine whether the following situations are reductions or enlargements, okay? If I'm given a scale factor, remember it goes from the image to the pre-image, okay, of 2 to 5. That means my image is smaller in terms of, if we're writing this as a fraction, okay, this would actually be 2 over 5 if we're writing as a fraction. That scale factor is less than 1. So actually, we can actually include that in here. If my scale factor is less than 1, okay, so if your scale factor is less than 1, in other words, we're talking about a fraction, then we're going to have a reduction. And I'm not worried about the sign right now. We'll talk about negative scale factors later, but I'm not talking about if it's positive or negative. I'm just talking about the number itself of the scale factor. In other words, its absolute value. If the absolute value of the scale factor is less than 1, then we have a reduction. If the scale factor, just the number, keep in mind we're talking about that absolute value, is greater than 1, then, we have an enlargement. Okay, so we'll use that like in this example here, 2/5, that's less than 1. In other words, it's going to be a reduction, okay, and that's what they say there. Same as 2/5, which is a reduction. In the second image here, remember the order matters here. We're going A, B, C to A prime, B prime, C prime. Well, what does that look like? That looks like a reduction, right? Because A prime, B prime, C prime is smaller than the original triangle. So that would be a reduction, okay? Now, this is given to us in that transformation form. It says we have the dilation about our center of dilation O, and this guy represents the scale factor K, which is 5. Since my scale factor is 5, that's greater than 1, what is that going to be? An enlargement. The scale factor is 5, so we have an enlargement, okay? So remember, we're not worried about if it's positive or negative when we write down this rule. We're just saying the number itself. If the scale factor is less than 1, it's going to be a reduction. If the scale factor is greater than 1, then we have an enlargement, okay? Then we'll go over the rest of these examples and how to find the center of dilation tomorrow.